So this week I made good headway for chapter 10. First 46 problems, section 10. There were 19 proofs. I'm at 40.3% of all the problems in Gallian, 681 out of 1688. And up to now, there's been 320 proofs. Time of filming, September 6th. Even though these, I'm fairly ahead in my schedule, putting these out about roughly 12 pages at a time. But I want to keep it so that in case somebody in the future wants to do this, you will have roughly a week's worth of work, even though I'm completing a little more than a week's worth of work these days. Yeah. So then, also read all of section 11, which I'm not showing here. I'm only going to show these problems for section 10. I've already shown the book last time, but I'll make a note. I'll show it again just so you can see what we're covering. So it's all about group homomorphisms. The definition itself, it's a multiplicative function. The kernel, a bunch of theorems about how all the subgrouping works. Some examples of how the group homomorphisms work. Yeah, some examples. But I have to say, in summary, for this section, given that I'm almost done with the problems, even though I'm filming only the first 46, again, just to keep it in batches. I'm actually like 2 problems away from completing the whole section. I think Gallian really could have done a lot better in this section. That's just my opinion. I'm not sure I'm qualified to make that sort of assessment. I did pick up a homomorphisms handout from Keith Conrad, which I would add to my notes. I haven't been doing this so much in the last year or so, maybe in the last 2 years, but this is an exception. I felt that there was so much to fill in for what Gallian did not cover, and I'll talk a little bit more after I show the problems. I have more to say. Yeah, so this is the last page of section 10 reading, and then here we go with the problems. Yeah, I didn't get 5 correct. I got 1 correct. That was pretty straightforward. I got these flipped. I spent a lot of time thinking about why it was h over k and not k over h. Yeah, I'm just going to leave it at that and come back to it. But yeah, I thought it was k over h. The order of k over the order of h. Yeah, I was very close on 9 on the proof. Yeah, just showing that it's a homomorphism. Then for this one, yeah, I could have done a little more. I could have actually laid out what the homomorphism function itself was. And I didn't do that, so I gave myself 3/4. Then more okay work. Yeah, the book states it differently, but I did do it correctly. Figure out what the kernel was. I'm sorry, what all the mappings were to equal 9, not the kernel. The kernel was given. Yep, another simple proof that I got correct. Yeah, here's where I started running into trouble. I started really not understanding what I was doing, and I stopped. Well, I did a couple of problems that I could do. I was close on this one, and I got another calculation problem as well. I got it correct. But by the time I hit this page, I was like, I have no idea what is going on in here. I just don't know what I'm doing. So I went and I read a bunch in the Dumb It and Foot. Yeah, so at some point, let me see, where did I start? I guess I got farther in, and I still got some more questions correct. Yeah, I still got questions correct, but at some point, here it is. Here it goes. Yeah, so even though I made it through these problems and I was able to get them correctly, it still lingered on my mind back at 25, explaining what the homomorphisms were between Z20 and C10 in both directions, that I just didn't do it right. I'm like, and then also here, I felt very uncomfortable. So then I went into Dumb It and Foot, And I also got this handout, of course, that I already showed. So I'll bring in Dummett and Foote and compare it to how it is done with Gallian. It's an important example. I may make a video later on about this with more, but maybe this is all that I will do. So in the case of Gallian, he's got 3 homomorphism problems. The second, third, and then there's a fourth one in Dummett and Foote are derivatives of the first one. Okay, so all it is the factor group G of the kernel of phi maps to phi of G, and therefore G of the factor group G kernel phi is isomorphic, not homomorphic, isomorphic to the mapping, which is really G bar. Okay, and also what's really important about that is that every normal subgroup of a group G is the kernel of a homomorphism of G, some homomorphism. That turns out to be very important. Okay, and that really was a key. So Gallian does cover that, but then in the case of Dummett and Foote, they really do it. They really do it. And so I read all of section 3, most of section 3.3. They show the first isomorphism theorem, then the second one, which are really, again, you just take G over kernel, and then you start doing more factor groups and different ways of subsectioning what you already stated in this theorem. At least this is my reading of the theorems. Yeah, and then the third one, again, more factoring. See now the factor group G of H, a factor group factored into another factor group is this isomorphism. Okay, yeah. So, and some examples, which I didn't follow through. I didn't read this far because I do want to do Dummett and Foote, and I got what I needed to keep going. And it sure worked out because, and I'll show this in the next video, I was able to make a lot more progress further down the line with some other help from my friends on the interwebs. Yeah, so then I started understanding a little better how the subgrouping works from my reading. This is just the reading of Dummett and Foote. And then things went a little better. Well, in the case of 43, the correct answer in the book, I did something different. And at first I thought, no, I gave myself a check mark. I did it correctly. But my statement of the proof is so different from what the answer is that even though I think this works, okay, so yes, let's take the problem. The only homomorphism from A4 to a finite group G where the order of G is not divided by 3 is the trivial mapping that takes every element to the identity. Sure enough, in the case of A4 with order 12, you have 1, 2, 3, 4, 6, 12 are the possible subgroups. But the ones that are divisible by 3, which are 3, 6, 3, and 6, are fine. You get homomorphisms. But the ones that are 2 or 4, you don't. And then you have to go through why. Well, in the case of 4, you would have to break it up. In the case of 2, you'd have to break it up in 6 by 6 chunks of the 12 by 12 KD table. And that just doesn't map. And in the case of 4, you'd have to break the KD table into a 4 by 4 grid, which just doesn't map either. It just doesn't map. And that's why the only thing you can do is send it to the identity. I feel that's correct, but the book has a much better explanation, and that's fine. Yeah, by the time I got to 47, I was understanding what I was supposed to do, and sure enough, I did answer it correctly. So those are the problems, and I showed the sections in the book. Yeah, and I wanted to show, I think I did not show in Gallian, that's what I forgot to do, is how Gallian does the homomorphism theorems. So it states the first one, and then the second one and the third one are in the problems. Section 10. Here they are. That's it. So they state, so Gallian leaves the second and the third isomorphism theorems for the problems. That's not good. And I'll have a lot more to say about that in the next video, because then I went on and did a whole bunch more homomorphism work to understand these concepts. And I feel I'm okay now. And you'll see it in the next video.